So without further ado, let's talk about the photoelectric effect, right? And to guide you in thinking about it, right, ask yourself, what is the photoelectric effect? And number two, what are the four key observations of this effect? Okay, so uh, generally, right, in a metal, you have a positively charged nuclei and a freely moving electron. Because the positive charge and the negative charge are attracted to each other to remove the electron from the metal, you will need to put in energy.
So the definition of photoelectric effect is hence the phenomena of electrons being ejected from a given metal surface when electromagnetic radiation above the threshold frequency falls upon the surface. So in this definition, there is an actor, which is the electromagnetic radiation that's incoming. There is a metal that's being acted upon, and there's the electrons that's being ejected. And here I want to point you towards the word electromagnetic radiation. If you look at some of the books or even online, some people define this as instead of saying electromagnetic radiation, they say it is when light above the threshold frequency falls upon the surface. Why do they say that? It's because usually, in this case, in the photoelectric effect, it is usually ultraviolet light that causes electrons that come out. So in the old definitions, I wrote the word light. But when I thought about it, I felt that I was a little bit uncomfortable because light could mean visible light. So to prevent any misunderstanding by Cambridge, I've decided to use the more rigorous definition of electromagnetic radiation. Why do I not use the word ultraviolet light then? It's because sometimes visible light can also produce a photoelectric effect. So I referred to the Cambridge textbooks. Uh, it seems they also use the word electromagnetic radiation, so let's stick to that. Next, in the rest of the chapter, when you hear the word light or you read the word light in the notes, I want you to remember that it is how it is explained, right, in many lectures and in many textbooks. Uh, but I want you to remember that I'm referring to usually ultraviolet light.
So this is quite well expressed or observed in what we call the electroscope. This is an electroscope, right? In the neutral state, when the top surface is not charged, you have the thin film, the branch, laying flat along the main stem. When it is charged negative, right, because of the repulsion, so it's basically like a leverage, right? This leverage is hinged at this point. So when it's charged, this branch will branch up like this. Okay, due to the repulsion force between the main stem and the thin gold film, right? It's a thin gold leaf. So in the scientists tried shining UV light, ultraviolet light, on the top zinc plate, and they observed, of course they can't see the electrons flying out, right? They observed that the gold leaf started to decrease in divergence. So they postulated that that was due to, right, when it diverged less, it means the repulsion force is less. They postulated that that is because electrons were leaving the zinc plate at the top, right, leading to an overall decrease in the number of negative charges held by the zinc plate and stem. Okay, so they say, oh, they realize that photoelectric effect takes place, right? A UV light of reasonable frequency causes electrons to leave the surface of a metal. Okay, so one of the names that they give these electrons, because they were the result of a photo, meaning light, of a result of light, and UV, this is a photoelectron. Okay, there were four key observations in this experiment. They realized that you couldn't just use any light, it needs to be of a certain frequency. Secondly, the moment you shine light on the surface, the lift decreased in the divergence. It was instantaneous. Number 3, there was a maximum kinetic energy of photoelectrons, and it's independent of intensity of light, right? And we'll talk about this in more detail later on. I'm sure this is not very clear now. And number 4, the rate of emissions of photoelectrons, the number of electrons being emitted, is proportional to the intensity of the light. So here, I give you the acronym, right? T, or if you take the first letter of the key words, this TIMIRP, and I challenge you to form a memory mnemonic to remember what is being done here. And when I asked this of the lectures in previous years, one of the students very creatively came up with this mnemonic, right? The Indian man invented roti prata. So this is not in any way, hope you don't take this the wrong way. This was proposed by a Indian student, so definitely not racist. Huh? The student himself is Indian. So he proposed the Indian man invented, and this is factual, right? I hope. But it is very easy to remember, right? So T, threshold frequency, the Indian, instantaneous, man invented, right? Maximum K, independent of intensity of light, and roti prata, the rate of emission is proportional to the intensity of light. I love this way to remember because I love roti pratas, right? So yummy. So one of the things that we noticed in these 4 observations is that with the electroscope, you can only observe 1, 2, and 4. Right. Point number 3, we'll use a more elaborate setup to explain in a later